This is factored form, so we're going to graph a parabola or quadratic equation in factored form. So let's make a prediction. Because the number out front is negative, we know it's going down. And the nice thing about factored form is this set equal to 0 and this quantity set equal to 0 will tell us what the x-intercepts are. You can leave it right now as a fraction, or we can put it into decimal form, which most people prefer. So either grab your calculator or do mental math. What's half of 7?
3.5.
Thank you. And obviously half of 1 is 0.5. So here is the decimal version, and here's the decimal version. Set each one of these equal to 0 and solve. Could you do it in your head? Sure you could. So x equals negative 3.5, negative 3.5, and positive 0.5. Those are the two x-intercepts, negative 3.50 and 0.50. You could also write those as a fraction. Graph them, negative 3.5 and positive 0.5. Okay, think about the number line. If somebody said make a dot at 0.5 and make a dot at negative 3.5, and I said, what is the distance between those two? How many units would it be? Let's count. Okay, so we're at 0.5. 1, 2, 3, 4. 4 units. 1, 2, 3, 4. Half of 4 is 2. So either moving from the left inward or moving from the left inward or the right inward, we're going to go 2 inside. So 1, 2. So x equals negative 1.5 is the equation for the line of symmetry. Remember, this value will always be the x value for the vertex. Okay, now let's make our life easy. Grab a calculator and press clear. We're going to substitute negative 1.5 in wherever we see an x. So first let's start with the negative sign, which you can find underneath the 3. Then do a parenthesis. Again, I'm substituting negative 1.5 in for x. So negative 1.5 plus, and yes, I could do 7 divided by 2, but as Andy already told us, 7 divided by 2 is 3.5. End parenthesis. Next parenthesis. Negative 1.5 subtract 0.5 end parenthesis. Press enter, and this will be your y coordinate for the vertex, positive 4. Go along here to positive 4 and make a dot. Okay, so whenever you find a y-intercept, by the way, every quadratic function has a y-intercept. Remember, every quadratic function, whether it opens up or down, has a y-intercept. And for y-intercepts, x will always be 0, so put a 0 right there. So I'm going to substitute in 0. 0 plus 3.5, okay, that's 3.5. There's a negative sign out front, and 0 minus 0.5 is negative 0.5. Grab a calculator and please do the math. Here's my negative sign. There's your 3.5 times negative 0.5. I have 1.75. Hands up high if you have 1.75 as well. Okay, so 1.75, estimate it. And now we get to cheat. So watch this. This point is 1.5 away from the line of symmetry. So go 1.5 to the left. There's a half. There's 1, and make a dot that is horizontal to this one. I have 5 points. Domain is negative infinity to positive infinity. Range, there's no limit how low it goes. It goes up to a y value of 4 and it's included. Please cross this out and write max. Your maximum value is y equals 4. From left to right, it is increasing. Okay, it hits neutral, and then it begins to decrease. Increasing, neutral, then begins to decrease. So I'm going to come over here. Remember, 2 things to remember about increasing and decreasing intervals. The first one is you always use parentheses. The second is we always identify in terms of x values. So increasing, it comes from the far left, and it continues to increase to an x value of negative 1.5. Decreasing starts at negative 1.5, and this is where it's very common to see a mistake. Students want to write negative infinity because they see it going down. But in terms of x values, it's headed to the right, which is described as positive infinity. End behavior. As you go to both the left and to the right, it's headed down.